Hi guys. Okay, seems I've in the BlendSpace this BlendSpace explained concept kind of missed out on a little bit of important information of exactly where the input information comes from. So I'm going to fill that in a bit here as an amendment to that particular video. I'll try posting the link to the original in the bottom there, and maybe post a pointer in the original video. But basically, if you follow any of the animation or character third-person tutorials on supplied by Epic, it'll explain to you right from square one of how and where to set up your character control inputs, and that's usually the derivative of the whatever character blueprint that you're going to set up to allow for customized characters. So that would be a tutorial all on its own, but these tutorials are pretty straightforward of how to set up your keyboard inputs and how to set up your mouse inputs. So I won't lag too long on those types of requirements because they're much better explaining to it. But what I'm going to do here is kind of give an overview of what you missed based on our design. I'm not going to do a full-out tutorial, but if you understand the idea of what it takes to get a control input into an animation blueprint, then this will become second nature to you. This is if you know how to set up follow those tutorials, then you already know how to set up controlled input by casting for it. But in this case, the BlendSpace overview that we're doing is based obviously on our customized design ideas as to what a BlendSpace is and how it'll be we built these necessary assets as part of our ongoing project here. So it's more of a technical white paper done as a video tutorial. But to explain where the keyboard information is coming from, it's coming from the same place that you normally would if you were using a character blueprint input for keyboard and mouse. But in this case, we're using a C++ class as part of the shooter sample, which we elected to use as our base framework from the beginning, which is like 99% changed from its original shape. But we're still using the C++ class of the shooter character, so we need to put all our control information in that character and then cast for whatever control is being activated from I believe, as you can see, it's called shooter character, which then translates into movement within our anim graph, which is this here is my test patch. Just to kind of go off the side here a bit, this is how I sort of develop logic blocks, because once I get the logic block working, it's just a matter of just selecting it, go and then Control C, Control V, copy it into our actual on-the-fly animation blueprint that we're working on for the game actual. So this way, I can test it without worrying about breaking something else down the line. But in this case, enough explaining that. To get the information we need, of course, we have to cast for, be it a character blueprint or in this case, our C++ class for the information as to controlled input, be it, as I mentioned, hopefully, keyboard or the mouse. Now, you may not know that this is required because you cannot, as far as I know, you cannot pull for controlled keyboard input or mouse directly from within an animation blueprint, so you would need basically a controller type of input. This is this is annoying, because if just you want simplicity, you should be able to do that from you should be able to pull for whatever kind of input you want from anywhere you want. But it's also good in a sense that there are different types of input, particularly, let's say, for example, VR glasses, where you need to track the glasses and not track your mouse. So this is where the input would come from, and then you would manipulate that within our case, this pathway here. Now this is why things get kind of lost, because obviously we need to apply a variable, a local variable, so that information can be used properly in the anim graph as far as getting that once we have that information from whatever character we're casting to, as far as input goes. So in keyboard input, for example, is pretty straightforward. Now this here, obviously, at some point as we go along, is going to become, well, a little bit more bigger as far as control input goes, and keeping things nice, neat, and tidy by placing it all into a single package, either being a function or as a macro. So in this case, I believe you're doing these as functions, and they seem to work properly. But as you can see, to get the information we need to be able to apply a working variable, since we are using in place and we're taking information from the movement component, we need to change things like we're changing things like velocity to a direction, as to a direction as to a speed. Now this is looks different than what you would normally, our blend spaces look a little bit different, because what we're doing is we're controlling direction, and then we're letting the capsule control velocity. So this is all we need. Is it left, right, is it forward or backwards, by grabbing the keyboard input and converting it into a value of being 1 or -1. So that corresponds to being either 1 or -1 on the blueprint. Okay, hopefully that will make sense. So this converts, as far as I know, it converts velocity to direction. Okay, so this pops out, and of course once that's set, we move down the pathway from the event update, and we move to the mouse yaw and pitch input, so we can assign those to a fixed set value once it's exit out. So once again, in this case, we are actually polling the information as to the actor control rotation and actor rotation, which then fed into a rotator, and it does all the things that are necessary as far as creating a output as to the input of that particular cast. So each time we move the mouse, our pitch and yaw is this is where it's updated as far as making a rotator and angle changes, which then is finally obviously outputted to our animgraph. Okay, this here is where we're patching it in, and we're only using pitch because yaw is going to be done to a different manner, and it's just in this case, it's just making the variable available if we decide. And as I mentioned, this is just for testing purposes anyways, to sort of plug in different things and see how it's going to work within the logic. So in other words, if this works, this is a blend per bone that includes the pitch control, but it also adds idle expression, eye movement, and eye blink type of animations as part of this layering. So we can add another layer here for doing dialogue and what have you. So it's once we got the logic block built, Control C, Control V it into a different application, break the chain, and then add the block in as a separate element to it. And then of course over time this becomes bigger and bigger and bigger. Okay, so hopefully that's a little bit more in depth, but this is where these two functions, this is where the actual input comes from, which then manipulates the whatever it is we have set in the atom graph. Sorry I missed that out, but as it's a little bit wordy, and our guys on our team already know how this stuff works, so I kind of omitted it. Well, intentionally, let's say. Okay, see ya.